How's it going, guys? Vlad here, and welcome to a review of a tutorial that became very popular, which is the Arduino tutorial number 3 on shift registers. So what I wanted to do today is demonstrate how you can chain the shift registers one after the other, because a lot of people have requested that functionality, and there have been some mistakes in the code, so I'm also going to update the code, and you can get it off my website. The link's going to be down below. So let's really quickly review these guys. The very simple shift register 74HC595, and I'm going to show you briefly how I connected the whole circuit, and we'll go from there. You'll also learn what changes you need to make in the software in order to make this work. So let's get started. Alright, so going through my color-coded circuit, you can notice that the first 7 pins on the IC are all going to the LEDs, so those are your shift registers, essentially pin 1 through 7, and actually the first pin is on the other side. If you can see, that's pin number 15. It's also an orange pin which goes to the first LED. Pin number 8 is your ground. Pin number 9 is the shift out. So this is the pin which will allow you to chain as many shift registers as you want. Essentially what it does is it outputs the last bit from this particular register onto whatever you connect it to. Going through this mess of wires, pin number 10 is a power pin. Pin number 11 is the clock that is labeled by a white wire in my circuit. So as you can see, I have a clock coming from the Arduino, and then I have a clock going to the next shift registers. So it's just the same clock that I have used in my previous tutorial. Next we have the STCP pin, which is the storage register clock pin. And once again, these have not changed from the previous tutorial. These are going to be all the same in the software. What do you have next? Next we have a ground pin, followed by the blue wire, which is the data pin. This is actually the shift register data that we're sending onto the shift register. Then we have the before mentioned LED 1 pin, which is once again an orange, and finally you have a VCC pin. So the second register, once again, you have all your LED pins in yellow. You have the same power and grounds. You are getting the same signals. The only difference is that your data pin in this case is coming from the previous shift register. So as you can see, this green wire is, as I explained earlier, the output of my last shift register. So essentially shift register 1, the first one, pin number 9 is going to go to pin number 14 on the next shift register. And all the other things on this breadboard are fairly self-explanatory. You have your ground bus for the resistors after the LEDs, and once you pull the LEDs high through the shifts, you will light them up. So let's take a look at the modifications in the software, and let's go from there. So a mistake that was corrected by my viewers in the previous tutorial was this minus instead of the plus. I did correct it when I made the video. I recorded the my programming and then realized that I had made a mistake and just kind of forgot to re-record the video. So there you go, this software should work. I have loaded it onto my Arduino right now, and the LEDs are blinking as expected. So let's just quickly go through it again. I'm defining the 3 pins that I'm going to be using, the data pin and both of the clock pins. In my setup, I define them as outputs, and I create a function write register. I set up, in this case, 16 registers instead of 8 because I have 16 LEDs to play with. I'm writing the clock to low. I'm going through a full shift of the whole register, so I'm writing 16 registers in one shot, and then I'm pulling the clock back to high. So in my loop I go through 2 sequences, so I increment by 1 LED going high. So again, this changed from 0, before this was 0 to 8, now it's 0 to 16, you write them to high. And in the case for the low, you go from 15 to 0, before this was 7. So nothing minor, I just wanted to show you guys how you can chain these shift registers as much as you want. And keep in mind, you can add multiples of 8, or you can control less pins with other shift registers if you want, but you can always increase. Essentially what you would need to increase is this, you would need to increase this, you would need to increase this, and then this, in order to add 3, 4, 5, however many shift registers you would like, and you should be all set. One thing you want to keep in mind is that, and I've mentioned this in my other tutorials, is that the Arduino is not going to source as much an infinite amount of power, so you kind of want to start strategizing towards other sources. If you're gonna drive, I don't know, over 20 LEDs, you're gonna have to check your data sheets for that. But that's just something to keep in mind, that you can actually burn the Arduino and the voltage regulator that's located on the board. So be careful with that. And once again, if you have any questions on the shift registers, or have any ideas of tutorials that I can make next, please let me know in the comments below. Thank you again for watching, and make sure to subscribe and let me know how you enjoyed the video. Thanks. Bye.